The final nucleophilic acyl substitution reaction of carboxylic acids we're going to look at is the DCC reaction, which allows you to convert a carboxylic acid to an amide. And what DCC is, that stands for dicyclohexyl carbodiimide. What it looks like, kind of an unusual structure. It looks like this. Basically, what this does is it works by converting the OH into a good nonpolar or a good non-protic leaving group. So what you can imagine is if you have some carboxylic acid and you try to react that with an amine, just say methylamine. The problem with this is that rather than substituting the OH like you might want to do to form the amide, you have the amine, which is a good base, the carboxylic acid, which is a good acid, and all you get is an acid-base reaction. So you get the carboxylate, and the protonated amine. So you get that ionic compound, which is pretty stable, and you're kind of stuck there. It takes really forcing conditions to get the amide to form. So what DCC does is, like I said, twofold. It will convert this OH into something that doesn't have the proton and converts it into a better leaving group. So now if we look at the same reaction with DCC, and I'm going to significantly oversimplify this mechanism for you. If you're interested, it's probably in your book or you can Google it, but basically I'm going to oversimplify it by just adding the DCC to the oxygen. So what you effectively end up with is an intermediate kind of like this. Then from there, the amine can add to that. Because now you no longer have the proton on the oxygen. So I'll draw one more just in brackets to specify it's an intermediate structure. I went ahead and took the proton off of the nitrogen because we're not going through a full mechanism here. Then what you can imagine, that negative charge comes back down. You lose that leaving group, and what you're left with is the amide. So this isn't a mechanism you really need to worry about trying to know, or even knowing the simplified version here. Basically, for the DCC reaction, just make sure you can predict the product for this.